we've got circles, and we have a center here at x, and it says that the line with this equation is L, which is this line here. Given that L is tangent to C at the point N, show that the equation of the straight line through X and N, so this straight line here, is given as that. Okay, well that's fine. So this straight line here we know is at 90 degrees to the tangent as per the circle theorem that tells us that. So these two lines are going to be perpendicular. So we know that the gradient of the line L is equal to 5 over 2 because it's in y equals mx plus c form. So therefore, the gradient of xn is the negative reciprocal of that, which will equal minus 2 over 5, because perpendicular gradients are the negative reciprocal of one another. Okay, and we also know a point. We know this point here is on the line xn, so we can use our formula for a straight line, which is y minus y1 equals mx minus x1. You could use y equals mx plus c, of course, but this one I think is a bit better, particularly when you want it in this form, and I'll show you why. So we do y minus the y value that we know, which is minus 3. So y minus minus 3 is y plus 3. The gradient is minus 2 over 5, and it's x minus the x coordinate, which is 4. Okay, so what we can do now is we can multiply both sides by 5. So multiplying the left-hand side by 5 will, well, just make this 5 times bigger. And multiplying the right-hand side by 5 will get rid of this divide by 5 here. So we just get this. And then we can just expand out this bracket, like so. And then we can bring it all over to the same side. So we plus the 2x over, we're going to get positive 2x. 5y stays the same, and then we take 8 away from 15, which gives us 7. And there we have the answer as required. Okay, part B, it says hence find the coordinates of n and an equation for c. Right, so the coordinates of n, well, n is right here, and that's where the two lines meet. So we need to solve simultaneously the equation of y equals 5 over 2 x minus 55 over 2 and the line we've just shown, which is 2x plus 5y plus 7 equals 0. Okay, so perhaps the best thing to do here is just solve them by substitution. So I'm going to sub this one into here. So we have 2x plus 5, and I'm going to replace the y with 5 over 2x minus 55 over 2, and then plus 7 equals 0. Okay, so this gives us 2x plus 25 over 2, which is going to be 12.5x, and then 5 times 55 over 2, I might need to use a calculator for that. That gives us minus 137.5, and then plus 7 equals 0. Okay, I'm just going to grab some more space. Okay, so we're going to simplify this up. We're going to get 14.5x, and this will be minus 130.5 equals 0. So we can solve here for x, and we get x is equal to 9. And then we need to substitute that in to one of the equations. So let's just pick this one here because it's already y equals. So y would therefore equal 5 over 2 times by x, which we know is 9, minus 55 over 2. I'll just put that into my calculator, and that gives us minus 5. So just to confirm, we'll write n. The x coordinate is 9 and the y coordinate is minus 5, and then that will be our final answer for part BI. Okay. So for part II, we need to find the equation of the centre. Well, we now know that this is at 9 minus 5, so we can work out the distance of the purple line, which will be the radius. So the magnitude of x to n, so the distance from x to n essentially, is equal to the square root of the change in the x's, which is 9 minus 4 squared, plus the change in the y's, which is minus 5 minus 3 squared. So simplifying this, this is 5 squared plus 2 squared, which is equal to the square root of 29. Okay, perfect. So the equation for C is as follows. So it is x minus the centre x coordinate, which is 4, as given by just the general equation of a circle, plus y minus the y coordinate of the centre. So that'd be minus 3, so plus 3 squared, and that's equal to the radius squared, which is going to be root 29 squared, which is of course just the same as 29. So there we have our final answer, and that is circles done. Okay, next question is vectors, and it says that we've got the point A and the point B as given, relative to a fixed origin. And it then says that C is such that ABC forms a straight line. And then we've got this information about the magnitudes. It asks us to find C. So the first thing I'm going to do is draw a straight line. And we're going to have A there, let's say, a B here, and C here. So all that matters is that they're on a straight line. And also, we're going to have the origin somewhere. Again, I'm not actually drawing this accurately, I'm just drawing a little picture to help us understand what's going on. Okay, so there's not much to take from here. We're going to have to use this information about the two magnitudes. So I'm going to write that, as it says here, the magnitude of AB over the magnitude of BC is equal to 2 over 5. So as a ratio between the two, we know that the magnitude of AB to the magnitude of BC will be the same as 2 to 5. So just swapping a fraction relationship into a ratio one can sometimes be helpful. So if we assign this distance here to x, then this distance here must be 5x, so that the distances between them are in that correct 2 to 5 ratio. Okay, so now if we could work out what AB is, what the magnitude of AB is, then we'd be able to go from A all the way to C, which would be helpful for finding C. Okay, so we need to find AB. So that is, and the fundamental vector equation, I guess, that you need to remember is that if you want to find A to B, it's OB minus OA. So in this instance, it is OB is the position vector of B, so we just look at the coordinates of B and write it in vector form, and then the same for A as well, like so. Okay, so let's add these together. So, subtract them, sorry. So 1 subtracted minus 3 is 4. 4 minus 14 is 10. And then minus 1 minus 5 is 4. Okay, great. So we've got AB. So if I want to go from O to C, then what I can do is I can go to A first, which we know because we know where A is, and then I can go along the top here and follow this line down, AC. So I could write that O to C is equal to O to A plus A to C, like so. And we know O to A because it's just the position vector of A, and we also know AC now. Because we know AB, if I divide AB by 2, I get X, and then if I multiply it by 7, I'll get all the way to AC. So it is actually 7 over 2 lots of AB. Okay, so OC is equal to OA, which is minus 3, minus 14, minus 5, and then plus 7 over 2 lots of AB, which we worked out was 4, 10, 4. So we can do this calculation. We get 2 times 7 is 14, minus 3 is 11. Divide by 2 is 5, times 7 is 35, minus 14 is 21. 2, 14, minus 5 is 9. But it does ask for the coordinates of C, and what we found is the position vector of C. So we have to be very careful here. We have to give our answer as a coordinate, which means as a row. So it's 11, 21 and 9 is going to be our final answer for C. Okay, question 3 is a proof by contradiction. So every proof by contradiction starts off with assume, and we want to assume that the the negation of this is true. So if we're trying to prove that A plus B is greater than or equal to 2 root AB, then the negation of that would be that it's not greater than or equal to, so it must be just less than. So we assume that if A and B are positive real numbers, then A plus B is less than 2 square root of AB. Okay, perfect. And then we're going to go and just do some algebra and hope that this ends up coming to a contradiction. So I don't like having square roots here, so I'm just going to square both sides of this, and this will keep the inequality the same. And if I square this side, I get, 2 squared is 4, and the square root of AB squared is just AB. And because these two things are multiplied together, when we square the whole side, we essentially square them individually and then multiply them together, which is fine. Okay, so now I'm going to want to expand this out to get A squared plus 2AB plus B squared is less than 4AB. And ultimately, a lot of these questions, you're trying to refactorize and get something which is just completely square, because we know that squares are always positive, so that proves to be a contradiction. So if I subtract the 4AB from both sides, this gives me minus 2AB plus B squared is less than 0. And if I refactorize here, this gives me A minus B squared is less than 0. And this is a contradiction. So we say contradiction as A minus B squared is square and always greater than or equal to 0. And then we have to write therefore, so a little conclusory statement. Therefore, original statement is true, but I'll just write it out again just because I just don't want to lose any marks. It's just might as well. So therefore, if AB are positive real numbers, then A plus B is greater than or equal to 2 root AB. Okay, now on to part 4, equations. So we've got this equation, and it says, importantly, that it has no real roots. So that means its discriminant must be less than 0. So the first thing I'm going to do is turn it into a quadratic by multiplying through by x. So we get 3 plus 5x is equal to minus 2x squared plus cx. Then I'm going to bring all the terms over to one side. So let's pick the left hand side, and that way that we have the x squared positive. So that becomes minus cx equals 0. I'm then going to write it out so that the x terms are together, and I'll factorise out the x as well, so we know exactly what the b term is when we look at the discriminant. So as we have no real roots, this implies that b squared minus 4ac is less than 0. Now I put that line in there just so the examiner knows exactly what I'm doing. So next, let's work out what the b squared minus 4ac is. Well, this is the b, and I have to square that because the b is the term, the coefficient of the x. Minus 4, the a is the coefficient of the x squared, which is 2, and the c is the constant term, which is 3, and all that to be less than 0. Expanding this out gives me 25 minus 10c plus c squared, and multiplying these together gives us 24. So that's less than 0. So writing this out and collecting up these constant terms gives us plus 1 is less than or equal to 0. Okay, so now we need to find the critical values. And we could do that by perhaps completing the square, or you could use your calculator. I've not got the calculator up today, so I'm just going to complete the square. So take away 25 plus 1. I'm going to set it equal to 0 here because I want to find the critical values as opposed to solving the actual inequality. So this gives us c minus 5 squared is equal to 24. And then this will give us c minus 5 is equal to plus minus the square root of 24. So c is equal to 5 plus minus the square root of 24. Okay, so those are the critical values. Now I'm solving a quadratic inequality which is less than 0. So if we look here, the quadratic I'm trying to solve the inequality for is less than 0. So so that means that we have like over here, one of our solutions looks like this. Over here, another one looks like this. And when the quadratic comes in, it will look like that. And we're looking for all the values which are less than 0. So therefore we're looking at all the x values which are along this line here. So our final answer will be 5 minus the square root of 24 is less than c, which is less than 5 plus the square root of 24. And that is our final answer for this question. And of course, if you were using a calculator, they probably would have simplified the surds, which is just equivalent, so I'll just write it out as well, like so. And that is also the correct answer. Okay, question number 5, and we have a function, and we're given 2 little bullet points. So that means that we're going to need to use both of these bits of information, and then set up a simultaneous equation. So let's start with the first one, and that is that x plus 2 is a factor, and of course by the factor theorem that means that f of minus 2 is equal to 0. So that is implied by that. So we could just sub in minus 2. So by doing so, we'll get a minus 2 cubed plus 6 lots of minus 2 squared minus 4 lots of minus 2 plus b is equal to 0. So simplifying that is going to give us minus 8a, and then that's going to be 4 times 6, which is 24. And then this is going to be positive 8, and that's going to be plus b equals 0. So we can say that, and let's write it over here, so minus a plus b will equal, and that's 32, move it to the other side, so minus 32. Okay, great, so that comes from the first bit of information. Can't take that any further, of course, because there's 2 unknowns, but then that can allow us to then set up the next part of the simultaneous equation, and that is that the integral when the limits of 5 and 3 are subbed in is going to give us 176. Okay, so let's get integrating. So we've got the function, and when we integrate it, we're going to up the power, so that becomes x to the 4, and then we're going to divide by the new power, and then that's going to be multiplied through by a. So we get a x to the 4 over 4. Next one, up the power, it's going to be x to the 3, and then we're going to divide by 3, and we've got a 6 in there as well. So next, up the power to a 2, divide by the new power, and there's a 4 there, and then next is just b up the power, it becomes bx. And then when we sub in 5 and 3, we are going to get 176. Okay, great. Let's just do a tiny bit of simplifying. 6 over 3 is just 2, so I could have just written 2 in here, like so. And 4 over 2 is 2, so again I could have just written 2 in here. Okay, now we need to sub in 5. So 5 to the 4 is, well, it's 625. Okay. 5 to the 3 is 125, times 2 is 250. 5 squared is 25, minus times by 2 is 50, and then that's plus 5b. So that's the first bracket. And then we need to sub in 3. Let me just get some more space. Okay, I'll do it down here instead. So let's sub in 3. So 3 to the 4 is 81, so 81 over 4, and then also multiplied by a. And then that's 27 times 2 is 54. That's 9 times 2 is 18, and then plus 3b. And again, all this will equal 176. Okay, great. So now we just need to do the calculation. Okay, so in terms of a's, we have 625 over 4, and then minus 81 over 4, and this gives us 136. So we've got 136a. And then in terms of constants, we've got 200 there, and we've got 36 there. So 200 minus 36 is 164. And then we've got 5b and then minus 3b. So 5b minus 3b is 2b. So that's plus 2b. And that equals 176. So 136a plus 2b is equal to, that's just 12 when we do 176 minus 164. We can divide this through by 2, that would be helpful. So that gives us 68a plus b equals 6. And then that will be our next equation that we'll need to use. So we've got equation 1 and equation 2. We can write them one above the other, and then we can subtract, and that will cancel out the b's. So this gives us 76a, because 68 minus 8 is 76, and then 6 minus 32 is 38. So a is equal to 1/2. Perfect. And then subbing back in to find b. Well, let's sub into here. In fact, no, let's sub into here, much easier. So that would be -4. Add it over, gives us -28. So b is -28. Okay, perfect. And that is job done. Question number 6, exponential modelling. We've got a graph here. And really important with any modelling question is just to highlight the units. So it says here G is in tons, and it says that T is the number of years after the 1st of January 1800. We've got our function for G, and we've got a sketch as well, and it's asking us first off to find the value of K. Well, that is right here, and that is when G is equal to 0. So we can start by writing for part A, we want G to equal 0. So 0 is equal to the formula for G, which is 40 minus 30 e to the 1 minus 0.05t. Okay, so what we can do is we can just rearrange this to get 30e to the 1 minus 0.05t is equal to 40, and then divide through by 30, which will give us 4 over 3. Then the inverse of e is natural logarithm, so we can write 1 minus 0.05t is equal to ln of 4 over 3. And then we can rearrange this to get 1 minus ln 4 over 3 is equal to 0.05t. And then we can just multiply through by 20 or divide by 0.05, same thing, to get this as the exact value for t. And of course, this is t, but this is when g is 0, so when g is 0, t is actually k. So we can finish this off by just saying k equals. We can put this into our calculator and we get a value of... Okay, so put that in the calculator and we get 14.2 essentially. So I will write here that k is equal to 14.2. Perfect. So next it says, hence find the year and month in which the gold started being extracted from the mine. So that is that is K. That's when it started being extracted. So we just need to use the fact that T is the number of years after the 1st of January to work out exactly when it was. So it's 14 years past 1800. So let's take away the 14 because we know it's going to be in 1814. So 1814. And now the month, well, that's kind of what's left over. So if I times that by 12, then it tells me that we will have 2 months already. So we've had January and we've had February. And then of March, we're not completely finished March. So it's right at the end of March. So essentially it is March. March 1814 is when the mine started being active. Okay, cool. So that's part that's part A done. Now part B, it says find the total mass of gold extracted from the mine up to the 1st of January 1870. So there, T is equal to 70. So we just need to sub that into our formula. So we say G is equal to 40 minus 30 e to the 1 minus 0.05 times by T, which in this case is 70. and that can go straight into our calculator. Okay, I've put that in my calculator, and we've got 37.5, and that will be in tons. Again, making sure we use the units as a modelling question. So 37.5 tons. And then part C, it says there's a limit to the mass of gold that can be extracted from the mine. State the limit. So the limit will be when, well, T sort of tends to a large, very large number. So we can put in a huge number here and see what happens. 40. There we go. It just says state it. We don't need to, show why it is the case. It just says state the value of this limit. So the answer is 40 tons. Job done. Question number 7. The functions f and g are defined as given. Solve the equation f of g is equal to 3. So this is a composite function. What we need to remember is that we need to take x, put it into g, and then put that into f. So putting x into g just gives us g of x, which is this, and then we need to sub in to this function. So we need to replace all of the x's with 5 minus 2x squared. Okay, so we can write for part A, f of g of x is equal to, so we're going to write out f of x, but every time we come to an x, we're going to replace it with 5 minus 2x squared, and then plus 6, and then that is all over. On the bottom, we've got x, so that's a 5 minus 2x squared, and then we have a minus 5. And that is equal to 3, as our equation states. Okay, so we've got a denominator there. We're going to get rid of that as quickly as possible by multiplying up. And we're also going to expand the numerator out. So let's expand the numerator. So we get 20 minus 8x squared plus 6 equals, and then on the denominator, in fact, let's just simplify this before we move up. We've got a 5 minus a 5, and we've also got a minus 2x squared. And that equals 3. Okay, so now we can simplify the top even more to get 26 minus 8x squared, and we're going to multiply the denominator to the other side. So timesing through by 3 gives me minus 6x squared. Then we're going to add 8x squared to both sides. That's going to give us 2x squared. We're then going to divide through by 2, and then we're going to square root. Now we need to be careful here. Check the domain. It does say that, well, look here, for g of x, x needs to be less than or equal to 0. So when I square root, yes, I will get plus minus the square root of 13, but in order for the domain to be satisfied for g, x needs to be a negative number. So the only answer that we are actually looking at is minus 13, or minus root 13, sorry. Okay, brilliant. So let's get some more space and we'll do part B. Okay, so it says find the inverse function of f. So what we need to do for that is we're going to need to write it out as y equals, which is 4x plus 6 all over x minus 5. And then we are going to swap the x's for y. And this is in fact just reflecting the curve in the line y equals x, which is what you do when you find the inverse function. So we're going to swap the x's for y's, like so. And then what we do is we then rearrange to make y the subject again. So we need to multiply through by that denominator, like so. And then we need to expand out. So hopefully you should be familiar with this technique from GCSE. And then we're going to move all the y terms to one side and move all the non-y terms to the other side. Then we're going to factorise out a y. And then finally we're going to divide through. So we get y is equal to 5x plus 6 over x minus 4. And then finally we need to write it as f of minus f of minus 1, which is the symbol for the inverse function, is equal to here 5x plus 6 over x minus 4. We also need to state the domain of the inverse function. Now, if we look at the original function, I've circled here in purple, you can see that the only stipulation is that x can't equal 5 because of the bottom. So over here on this one, the only stipulation we need to write is that x cannot equal 4 because of the bottom. Again, you can't divide by 0. So that is the restriction on this particular inverse function. Okay, perfect. Now it says sketch and label on the same axis the curve of y is equal to g of x, and also the curve of the inverse function of g of x. Show your sketch and the coordinates of the points where each curve meets or cuts the axis. Right, so this is a negative quadratic which has a y-intercept at plus 5. So we'll put that in there at plus 5. And a negative quadratic has this shape to it. But the restriction on x is that it is less than or equal to 0. So we're only looking at the left-hand side. So this part is the only thing we're looking at. What we are going to have to do is we're going to have to solve to find the root, to find this value here, because it does show where all the coordinates, where the curve meets the coordinate axis. So we're going to have to solve 5 minus 2x squared equals 0. So a bit of rearranging gives x squared is equal to 5 over 2. So here x is equal to just negative root 5 over 2. Because again, we're taking the negative part because it's on this side. It does say on your sketch, show the coordinates. Yeah, so I'll just put here minus root 5 over 2. Okay, perfect. So how do you do an inverse function? Well, an inverse function is always a reflection in the line of y is equal to x. So we just need to reflect it in that line. And I'll pick a different colour. Let's go for red. So it's going to come like this. And then like this. So that looks like a good reflection to me. So this point here will be 5, is the reflection of this point here. And this point here will be minus root 5 over 2, because it is the reflection of this point over here. Yeah, that's it. Job done. Okay, next up we have a classic binomial expansion. The first thing to look for with this is that you can see that it's a fractional power. So if it's a fractional or negative power, it means we need to use the formula for the binomial expansion, which is given in your formula book. And it looks like 1 plus nx plus n n minus 1 x squared over 2 factorial, and so on and so forth. I'll just do one more just so we're clear, like so, and that will be over 3 factorial. I didn't put the factorial in here, and that will be x cubed. Okay, so that is given, and the next thing we need to check is there needs to be a 1 in this slot here, which there isn't. So we need to take out a factor here. We need to pull out a factor of a quarter. So if we take out a factor of a quarter of this bracket, then this will give me 1 minus 5 over 4x. So just check if that's right. That's not right, in fact, because when you multiply this bracket out, you don't get this. So I made a mistake there. This, in fact, should be 20. And now let's check. When I multiply a quarter into this here, do I get this? Yes, that works. Okay. But this is to the power of a half. When you take out a factor of a bracket which is raised to a power, we have to take the power out with it. So we've got here a quarter to the half and then multiplied by this. And that is now in the perfect form for us to use the binomial expansion. So we can say that is equivalent to, or sorry, roughly equal to, approximately equal to, a quarter to the power of a half is the square root of a quarter, which is a half. So that goes outside. And then we can start using the formula here, such that the power is n, which is a half, and the x that we're going to be using is in fact minus 20x. Okay, so let's just follow the formula. So it's 1 plus nx. So again, n is a half, and x is minus 20x. Plus, and how many do we need actually? We need first 4 terms, oh gosh. Okay, so again it's n, which is a half, times by n minus 1, which is minus a half, and then multiplied by minus 20x, which then needs to be squared, and that is all over 2 factorial. And then the next one, I'm not sure if I'm going to be able to fit that in, let's just grab some more space. Move you up a little bit. Okay, so plus, this will be 1/2 times by n minus 1 times by n minus 2, and that is minus 20x cubed, and that is all over 3 factorial. Close bracket, just fit in nice. Okay, so we just need to simplify this all now, so I'm just going to keep the half outside. This becomes 1, and that becomes minus 10x. This becomes 400 over 8, which is 50, and it'll be a negative because there's one negative here. So it's negative 50x. And this will be 8,000 over, the 3's will cancel, over 16. So 8,000 over 16 is the same as I should be able to do that. 8,000 over 16. Having a mind blank. It's a half of 1,000, so it's 500. Right, apologies for that. How many negatives will there be? Those negatives will cancel, and then this negative will be there because of the cubed. So it's negative 500x cubed. This should be a squared as well. Gosh, I made a bit of a meal of that. I probably should use the calculator, to be honest. Okay, so we just have to half that now. So it's 1/2 minus 5x minus 25x squared minus 250x cubed. Perfect. Okay, right, I had to check that answer because of the mental maths, but that is right. Bosh. Okay, part B. Okay, now I know people find this difficult. It says by substituting in x is equal to 100th into your answer to part A, find an approximation from root 5. Okay, so what we're going to do, and what I always say to do for a question like this, is we're going to sub in that value of 100th into two things which are approximately equal, as we've shown. We're going to sub it into here, and then we're going to sub it into here. And again, like I said, both of those are approximately equal, which is fine because we're finding an approximation after all anyway. So subbing into the yellow is going to give me 1/4 minus 5 multiplied by 100th, and that is to the power of 1/2, like so. And then I'm also going to sub into the blue, which is going to give me 1/2 minus 5 times 100th minus 25 times 100th squared, and then minus 250 times by 100th cubed. Okay, so now we're just going to use the calculator. Okay, so first off, I've just figured out what that bracket on the left simplifies to, and it simplifies nicely to 1/5. I haven't put the square root on there, or the power of 1/2, so I'll do that now just by putting in a square root like that. Okay, perfect. Now I'm going to do the right hand side. Okay, so I've just subbed all that in, and I get a fraction as follows. And now what I'm going to do is I'm going to look to see exactly what we're trying to find, and that is root 5. Okay, so nice. So let's look at this left-hand side. This is the same as the square root of 1 over the square root of 5, which is the same as just 1 over root 5. And again, that's approximately equal to 1789 over 4,000. And then what we could do is just take the reciprocal of both sides. and that just gives us root 5 over 1, which is just root 5, and that's approximately equal to 4,000 over 1789. Or alternatively, I'll say alternatively because there are two actual correct solutions for this. What we could do is we could rationalise this left-hand side by timesing top and bottom by root 5. So if you times top and bottom by root 5, you get root 5 over root 5 times root 5, which is 5. And again, you've not actually changed the value of the left-hand side because you've just times it top and bottom by the square root of 5. You've just rationalised it, so it's still equal to this. And then you can multiply through by 5 to get root 5. So sorry, we should say now that root 5 is equal to, or approximately equal to, timesing through by 5. We'll keep this the same, but just the denominator will change to 800. Yeah, and that is also a valid answer. So both of these two are valid. Both of these two are correct as good approximations for root 5. Okay, a software developer released an app to download. The number of downloads of the app each month in thousands for the first 3 months of the app were released. Okay, and it says that it's modelled as a geometric sequence. Yes, that is what we're looking for here. Okay, so it's to show that question, and we need to work out essentially what k is. So if it is a geometric sequence, like they say it is, then to get from here to here, we would need to multiply by r. And then to get from here to here, again, we would need to multiply by r. So what we can say is, for part A, that 2k minus 15 multiplied by r will equal k, and also k multiplied by r will equal k plus 4. Okay, so we can make r the subject of these two equations by doing dividing through, like so. And over here we can do the same by just dividing through. Now both of these two equations are equal to r, so therefore they must be equal to one another, these two expressions. So this one must equal this one. Okay, next we can cross multiply to get k squared is equal to k plus 4 multiplied by 2k minus 15. We can expand out these brackets to get 2k squared plus 8k minus 15k and minus 60. And then we can set this equal to 0. So bring the k squared over. So subtract it from 2k squared. 8k minus 15k is minus 7k, and then we've got minus 60 at the end there, and that is as required, so that is an immediate bosh. Lovely. Right, on to part B. Okay, part B says predict the total number of downloads in the 4th month. Well, in order for that to happen, we need to solve for k, and this can be factorized. Minus 12 and plus 5, I believe, does the job. So therefore k is equal to 12 or k is equal to minus 5. Okay, now we know that it must be this one because one of the months there is actually k, so it can't be minus 5 because that wouldn't make any sense. We wouldn't have negative numbers of downloads. Also, I've just realised that I've done a cardinal sin here and I've not highlighted the units because that is important. It does say it's in thousands, so we need to remember that for this part of the question. Okay, so predict the number of downloads in the 4th month. Well, we've got the 1st, 2nd and 3rd. So, in order to find the next, we well, let's just write out the series actually, because we've got k now, so let's just do that. So 2k minus 15 is 24 minus 15, which is 9. So we start at 9, and then we go to k, which is 12, and then we go to k plus 4, which is 16. So we can see here that the ratio, the common ratio, must be 4 over 3, because when you times 9 by 4 over 3 you get 12, when you times 12 by 4 over 3 you get 16. So timesing 16 by 4 over 3 will give you 64 over 3. And that is, I'm going to need a calculator to do that, because then afterwards we need to times it by 1,000 because it's in thousands. So it's 64 over 3 multiplied by 1,000. So it is 21,333. So the fourth month, we'll call it A4, is equal to 21,333. Okay, perfect. Right, part C, it says the total number of all downloads of the app is predicted to exceed 3 million, which for our model is 1,000th of that because they're measured in thousands. So in fact, we're going to use the number 3,000. For the first time in the nth month, calculate the value of n according to the model. Okay, fine. So let's just remind ourselves what the first term is. The first term is 9, and the common ratio is 4 over 3. So we're going to have to use those when we're doing the summation formula. So let's just get rid of this working. And then what we're going to do is we're going to just write that down again. We're going to say A was equal to 9 and R was equal to 4 over 3. Now the summation up to n, the formula is A 1 minus R to the n all over 1 minus R. And we want that to be greater than 3,000. So let's sub in what we know. So A is 9, 1 minus R was 4/3 to the n, and that's all over 1 minus R, which is 4/3, and that needs to be greater than 3,000. Okay, so what is 1 minus 4/3? It is minus 1/3, and then I'm going to multiply that up to this side, which is, so timesing 3,000 by minus 1/3 is going to give us minus 1,000. Okay, now, so we can write this now as 9 lots of 1 minus 4/3 to the n is less than minus 1,000, because when you multiply by negative, you have to flip the inequality sign over. Okay, perfect. So now we're going to divide through by 9 to get minus 1,000 over 9. And then we're going to do a little bit of rearranging. So I'm going to say this is 1 is less than, I'm going to add this term here to the other side, which is 4/3 n, and then we've still got the minus 1,000 over 9, and then I'm going to add the 1,000 over 9 to 1, which will give us, let me just grab some more space. Okay, so adding it to that side, it will give us 1,009 over 9 is less than 4/3 n, and then when we've got the variable we're trying to solve for as the power, we need to take logs of both sides. So we're going to say log of 1,009 over 9 is less than or equal to log of 4/3 to the n. And what this allows us to do is bring the power down using the log rule, so we can write it like this. And then we need to just divide through. So we're going to get log of 1,009 over 9 over log of 4 over 3, and that is going to be less than n. Okay, so that can go into our calculator to get a value. Okay, and when we put that into our calculator, we get 16.4. So we can say that 16.4 is less than n, or n is greater than 16.4, which means that the first time that it exceeds it is going to be 17 years. Is it in years? What does it say? It's months. So it's the 17th month, or n is 17. That's all we need to do. Perfect. Lovely jubbly. Okay, question number 10. And we have a sequence which is defined with the first term is equal to 3. And then the next term is 2 minus 4 over the previous term. Fine. So U2, other than being a good rock band, is equal to 2 minus 4 over the last term, which is U1, which is 3. And 2 minus 4 over 3 is 2/3. Okay, so U3 is equal to now 2 minus 4 over the previous term, which is 2/3, which is the same as 2 minus 12 over 2, which is 6. So 2 minus 6 is minus 4. Okay, and then U4 is what we're asked to find next, which is 2 minus 4 over minus 4, which is 2 minus 1, which is 3. We're back to where we started. Perfect. And that's it. Right, part B. Find the sum up to the 100th term, starting with the first term of the series UR. Well, this has what we call a period of 4. No, sorry, a period of 3. And that is because we go from the first term, we jump 1, 2, and then 3, and we're back to where we started. So because U1 is equal to U4, this has a period of 3. And that means that these first 3 terms are just going to repeat and repeat and repeat. So we could go up to the 99th term and get 33 repeats of those 3 numbers. So the numbers are 3 and then 2/3 and then minus 4. And if we do that 33 times, we'll be up to the 99th term. And then we've got back to the beginning, well, not back to the beginning, but the next term along will be the same as the first term, which is 3, so we need to add that on as well. And there we go, there we've got the first 100 terms. So because these 3 repeat, we're going to repeat them 33 times, which gives us 99 terms, and then we're going to add on the next term, which is 3. So now we've just got to calculate this. Well, 3 minus 4 is minus 1, and then minus 1 plus 2/3 is minus 3, minus 1/3, sorry, so it's minus 1/3 times 33, and then plus 3. So that is minus 11 plus 3, which is equal to minus 8. Perfect. Job done. Lovely. This, I think, is the most common topic in EDEXCEL. It just comes up so frequently, and it's always for a decent chunk of marks. And it's just a great question. Okay, so we have to prove this trig identity, and of course we're going to start on the left-hand side because that is looking very juicy over there. Loads of different things we can do. And it's really not obvious what it is that we are going to do, is it? It's not obvious at all. I mean, we could do so many different things here. The first thing we're going to do, I know what we're going to do. Sine 2x is quite restricted. That is just 2 sine, let's write it down here. Sine 2x is equal to 2 sine x cos x. It's the cos 2x, which has loads of different forms, well, 3. It's cos squared minus sine squared, which you can then write as 2 cos squared x minus 1, or you could write it as 1 minus 2 sine squared x. So there's 3 to pick from. Now, what I notice is that we want it to equal cos x, so we need to get rid of the 2x's, basically. We need to get rid of the double angles and make them all singles. Now, which one am I going to pick for cos 2x? I literally don't know yet. So if in doubt, let's just go with the first one. Let's just pick it like that. So the left-hand side is cos squared x minus sine squared x all over sine. I already know which one. Oh, that doesn't matter. Let's carry on. It's all good. Plus sine 2x, which is the this yellow one here, which we're going to swap out for this. So that's plus 2 sine x cos x, and that is all over cos x. Okay, perfect. Right, so this is going to cancel, this is going to cancel. Now, cosec is the reciprocal of sine, so ideally I want to get rid of all the coses and just be left with sines. So in hindsight, in fact, I think I should have picked this one for cos 2x because that one has sines. So let's rewrite the top now as 1 minus 2 sine squared x all over sine x. And then we've got this plus 2 sine x there as well. Okay, now because we've got a single denominator, the numerator has two parts to it. We can split the numerator up. Of course, you can't split up denominators, but you can numerators. So this becomes 1 over sine, which is cosec x, 1 over sine here. So 1 divided by sine is cosec. Then it's 2 minus 2 sine squared over sine, which is minus just 2 sine. Because, well, if you've got a sine squared and you're dividing it by sine, you're just left with a sine. And then we've also got the plus 2 sine x as well. So this is just going to leave us with cosec x, as these two are going to cancel, which is equal to the right hand side. So we have proved our identity is true for all x. Perfect, well not all x actually, careful. We've got the stipulation here, but anyway, it's done. Okay, part B, and it says hence or otherwise we need to, oh no, it says hence solve, so there's no otherwise, we need to literally use this identity. Well, the first thing to look for is that when we have a question like this, the identity tends to be in terms of x, and then the actual thing we're trying to solve tends to be in theta. Now, is this a direct swap? This is a perfect swap, so we don't need to worry too much. We just literally can swap out this blue bit here, can be swapped out perfectly for cosec x, or cosec theta should I say. Okay, so this blue bit gets swapped out for cosec theta, so it just becomes cosec theta, and then it needs to be all squared, and that's equal to 6 cot theta minus 4. Perfect. Now, there is an identity which links sine squared and cos squared, and there's also two other identities that stem from this, and there's one that involves cosec squared and cot squared. Now, in order to find it from this original identity, we can divide through by sine squared on each term, because that will give us a cosec squared on the right hand side, just like this, a cosec squared, because that's 1 over sine squared. And then here we're going to get sine squared over sine squared, which is 1, and we're going to get cos squared over sine squared, which is cot squared. Okay, so that means that we can swap out the cosec squared for a 1 plus cot squared. So this becomes 1 plus cot squared theta is equal to 6 cot theta minus 4. Okay, perfect. Now let's bring everything over to one side. So we've got cot squared minus 6 cot theta, and then we've got the minus 4 comes over to plus to the 1 to make 5, and that equals 0. We can factorise this as it is a quadratic in terms of cot theta. We've got two numbers that times them over to make 5, add to make minus 6, so they are minus 1 and minus 5. That does the job. So this tells us that cot theta is equal to 1, or cot theta is equal to 5. Just solving that that bracket quadratic. Okay, so then what we want to do is convert it into tan, because tan is the reciprocal of cot. So if we flip over these fractions here, we get tan theta is just equal to 1. If cot theta is equal to 1, then its reciprocal is 1. And here, tan theta is equal to 1/5, because once again it's the reciprocal of cot, so we just take the reciprocal of both sides. Okay, smashing. So we just need to double check. Are we in radians or are we in degrees? We're in radians. So we need to do theta is equal to the inverse tan of 1, and theta is equal to the inverse tan of 1/5. So we'll do that on our calculator. Okay, so doing that for the first one gives us theta is equal to pi over 4. And then going over to this one of 1/5, we will get equal to theta is equal to 0.197. That's the three significant figures. Okay, perfect. Now this means that the value for theta is acute because it's between 0 and 90. And for tan, there is only one value, which is acute. So these are the two values that we need, and that is job done. Okay, question 12 is a bit of a grim question, to be honest, but that's kind of the reason why I put it in this paper, just to challenge people. I know a lot of people don't like these types of questions, particularly where you're asked to find the range as well. Anyhow, let me try and explain it to the best of my ability. Now, this is a 3-mark question, but it can be done very quickly if you know the kind of hack. And the hack that I use is I just look here at the fact that we're converting into a sine. So that means I call the coefficient in front of sine the a, and therefore the coefficient in front of the cos is the b. And that's all I need to know, because r is equal to the square root of a squared plus b squared, which in this case is equal to the square root of 12 squared plus 5 squared. And notice as well, I do not pay attention to this sign here or this sign here. It doesn't matter. I'm just looking at the number part. So 12, 5, always positive. And that equals 13. It's a Pythagorean triple. And then to find alpha, we just say, as always, alpha is equal to tan to the minus 1 of b over a. And this will work every time, as long as you select the a as the trig function coefficient that you are converting into. So this is 5 over 12, and this will have some sort of value. Let me find it, what it is. And in the calculator, it told me it was 0.395. Perfect. It just says give the value of r and theta in radians, alpha in radians. So I don't actually need to write out the r sine x minus alpha equation or expression. So we're good. And now it says this function is defined by this. So this is nasty. But what do we need to focus on? We need to focus on this part and see how that relates to this, what we've just worked out. So we have converted this, haven't we? Okay, so how do these differ? Well, I mean they're exactly the same as long as x is the same as 2 theta minus pi over 6. And then these two purple boxes are identical. And we said that we could convert this purple box into this guy. So therefore we can say that g of theta, so this is for part B, g of theta is equal to, there's a 10 there, which we need to add on. And then this box here is the same as this box, as long as x is equal to this, which is the same as this, which is 13, because r is 13, sine of x, but we're saying that x is equal to this, so 2 theta minus pi over 6, and then minus alpha, which we said was 0.395. So there we go. Now we've got g of theta in a nice new format, which is going to make it easier for us to find the minimums, the maximums, or whatever. So part I is actually asking us to find the minimum value of g of theta. Well, what I know about any sine function is the smallest output it can give is minus 1. If you think about the graph, the sine function, the smallest output it can give is minus 1. So if I'm looking for g theta minimum, then I just need to make that sine function there equal to minus 1, because that's the smallest it could be. And if that is the case, we get 10 minus 13, so we get minus 3. Perfect. And then it says the smallest value of theta, at which the minimum value occurs. Fine. Well, what we said was this sine function, we want it to be minus 1. That's when we get the minimum. So if I write this sine function out, like so, then I want this to equal minus 1 because that's where we get our minimum. So taking inverse sine of both sides, this is going to give me, it's going to get rid of the sine part here, and it's just going to leave me with the input, which is this horrible nasty thing. And sine to the minus 1 of minus 1 is, in radians, I believe, yes, we're in radians here, is minus pi over 2. So you can do that on the calculator. Now what I like to do as well, given that it says that theta is greater than 0, let's find out another value just in case. So we know that the sine graph looks like this, like so. And we've just found at minus 1, our calculators have told us that here at minus 1 we have a value of minus pi over 2. Well, let's just toot along and find the next one as well, just because it might be useful. So this will be 3 pi over 2. Okay, so that's an additional solution which we might need to use. Okay, well let's try and solve for theta now. And let's use the minus pi over 2 and see what we get. Okay, so I'm just going to show all the calculator work here, just so everyone's clear. So minus pi over 2 is what we'll start with. And we're going to have to add on pi over 6 to both sides. And we're also going to have to add on 0.395. And then we're going to have to divide the whole thing by 2. So let's just do that in one movement, like so. That was pretty nifty, wasn't it? Okay, see, we get a negative value for theta here. We get minus 0.32. And that's no good, 326, before people start having a go at me in the comments. Because it says here, theta needs to be greater than 0. So that's why we need to take the next solution for sine, which we've already worked out, is 3 pi over 2. So let's plug that in. So rather than starting with minus pi over 2, let's start with the next solution, which is 3 pi over 2. Add all the stuff over, divide by 2, and there we go. We get a nice positive answer. So as trig functions, they have infinite number of solutions. We just need to find the one which suits us best. And this is the one that we are looking for. Perfect. Okay, part C, and we've got a new function, in fact, but it still has that common theme of 12 minus sine beta minus 5 cos beta, which we know we can write like so. So let's just do that straight off the bat. So we're saying that this is equal to 10 minus, we know this guy is the same as 13 sine beta minus, actually need to put that in brackets. Whoops, let's get rid of that. Let's do that again. minus 0.395. And all of that needs to be squared. That's the difference here. Okay, so we need to find the range. So let's look for the smallest this could possibly be. Well, if I want HB to be small, this function to be small, then I'm taking away this square bracket. So I need this square bracket to be as big as possible. Okay, I want this to be as big as possible because I'm going to take it away, and that's going to give you my minimum. So HB minimum is equal to 10 minus, and the largest this yellow bit can be is when sign is 1, and then you just get 13 squared, which is equal to 169. So 10 minus 169 is minus 159. Okay, that's the smallest it could be. Now, the largest it can be is not when, so we're taking away the yellow thing. So if we want it large, we want to take away as little as possible. But it can't be negative because it's a square. So the smallest it could be is 0. And when it is 0, we're just doing 10 minus 0, which is 10. So therefore the range is in between the smallest, which it could theoretically equal, and the largest, which again it could equal. Perfect, so that is the range. Question 13, big dog, parametric integration and substitution. Love it, let's do it. So, where to begin? Where to begin? We're going to begin with the formula for parametric integration. And that is that the area, or whatever, is equal to the integral of a y dx by dt dt. So in order for us to do parametric integration, we need to take the x, which I could write as 9 minus 4t to the power of a half, because it's the square root, and I need to differentiate that. So I'm going to do that using the chain rule. So the half is going to come down, the bracket's going to stay the same, the power is going to drop by 1, and then we're going to multiply by the derivative of the bracket, which is minus 4. And a half times minus 4 is minus 2. So we're just going to write minus 2 here. Okay, good start. In order for us to do parametric integration, we need the limits to be in terms of t, which they already are. So perfect. Don't need to convert them from x to t. Great, that's a step saved. So now I think we're just ready to go then. So we can say that the region R is equal to the integral of, now the t, the limits are always the one furthest to the right in terms of x is on top. So 0 goes on top, and then the one furthest to the left is on the bottom. So that's 9 over 4 goes there. They are different down here, which we will get to in a moment, but this is correct. So it is 0 and 9 over 4. So next thing to do is y, which is t cubed over the square root of 9 plus 4t, and then we're going to multiply that by dx by dt, which is minus 2 over, this bracket is to the power of minus a half, so I could write it as on the bottom and as a square root, so 9 minus 4t, and then that is dt. Okay, great. Now, here's the trick. If you have the integral between b and a of f of x, then this is the same as if you basically flip the limits over, the integral gets multiplied by a negative. So we can take out a negative, just completely cancel it out, and what I can do is it can flip the limits over. So flipping the limits will allow us to cancel out the -2 there, or just the negative, sorry. But I can take the 2 out because it's a constant, so that has completely removed now this -2. So the 2's gone out and the negative has flipped the limits over. So on top we just have t cubed, and then on the bottom what we're doing is we're multiplying 2 square roots, and as you know, the square root of AB is equal to the square root of A times the square root of B. So because we can just multiply inside the square roots together. And what do we get when we multiply 9 plus 40 by 9 minus 40? Well, that's the difference of 2 squares. So we'll get, when we multiply this brackets, we'll get 9 times 9 is 81. We'll get 9 times minus 40 is minus 36t, and we'll get 4t times 9, which is plus 36t, so they cancel, but we also get minus 4t times 4t, which is minus 16t squared. But that is all under a square root. Again, this is using this third rule here, that you can basically multiply 2 thirds, you can combine them like so. And this is then dt. And I believe that is exactly what they want us to do. They say k is a constant to be found, so I'll just write k is equal to 2. And we are good. Yeah, perfect. We're good to go. Okay, so part B asks us to use this substitution down here, or otherwise to find the exact area. I think I'll just choose to use the substitution. Don't want to overcomplicate it. So part B. We've got this integral. Now if we're doing another substitution, then we've got to just rearrange everything again, haven't we? So the first thing I tend to do is I like to just take the substitution and differentiate it. So taking this substitution, differentiating, I get du by dt is equal to minus 32t. So du is equal to minus 32t dt. So du over minus 32t is equal to dt. Perfect, yeah. So that takes care of subbing this out. We'll do that over here. Next, we want to take care of our limits. So we have that t is equal to 9 over 4 and t is equal to 0. So subbing that into this substitution here, so 9 over 4 squared is 81 over 16 times by 16 is just 81. So 81 minus 81 is 0. So u is 0 for that. And for this one, we get, well, when t is 0, we get u is equal to 81. Okay, great. So that takes care of these guys. And now, under the square root is exactly what our substitution is in yellow. So that's perfect. So we've just got this t cubed, which is a little bit annoying. But if I take the u substitution and just rearrange it, this gives me 16t squared is equal to 81 minus u. So therefore t squared is equal to 81 minus u over 16. And I think that will be enough, because I think we've got this over t here, which I think is going to cancel this one down to a squared, and then we could just sub it in for this. So I think this will have this covered when we actually do our substitution. Okay, so we are ready to transform this integral. So it becomes r is equal to the integral between 0 and 81. There is a 2 outside, don't forget that. And we have on the top a t cubed, but we're going to sub in for t squared and then multiply it by t to get the t cubed. On the bottom we have the square root of the yellow bit, which was this, which is just u, and then we're going to multiply that by the pink bit, which is dt, which is du over minus 32. Okay, minus 32t, sorry. And then as anticipated, the t will cancel like that, and that is just in terms of u. Perfect. Now let's integrate it. Okay, so let's call it r. And what have we got here? We've got 2. And I'm going to take out this 16th here, which is on the top. So we could take it out side, which is 1 over 16, like that. And then we've got 0, and we've got 81. Now this becomes 81 minus u over u rooted, which is u to the power of a half. And this is multiplied by du over minus 32. So in fact, I'm going to take that minus 32 out as well. So we're going to have 2 times the 16th times by 32nd, which is the same as minus 1 over 256. And that's between 0 and 81. So the minus has come out from here. And then we've got this 81 minus u over u to the power of a half du. Okay, we could do that neat trick again. Because if we just take out this negative here, we can flip the limits over. That just becomes a bit nicer. Okay, now what we can do is we can just write this in a more integratable form. So this is a denominator, it's a single denominator, so we can literally take the numerator and divide each term by that denominator. So 81 divided by u to the half is the same as 81 u to the negative half. And then u to the 1 divided by u to the half is just u to the half. Okay, fantastic. So now we can do the big square brackets and actually integrate this. So up the power by 1 goes to u to the half. Divide by the new power is we're dividing by a half, which is the same as timesing by 2, which is 162. And then up the power u to the 3 over 2, so up it by 1, and then divide by the new power, which is going to be the same as timesing by 2 over 3. And that's between 81 and 0. Okay, brilliant. This just needs to go into the calculator now. Okay, I've plugged it into the calculator, and the zero limit will just give us 0, so it's just the 81 limit, and it gives us 243 over, oh, I've forgotten it now, whoops, 64. Okay, perfect. What I would do in an exam is I would evaluate these individually. I'd evaluate that, write it down, and I'd evaluate this, write it down, and then I'd write my final answer. But to save time, I'm just writing the final answer. Okay, a lovely little differentiation question here. So we've got a function, and simply it just asks us to find the derivative function. And it is a quotient because you can see it's a fraction. So we're going to do the quotient rule in full. We're going to write u, the numerator, is 2x plus 5 squared, and v, the denominator, is x minus 3. We're going to find du by dx, so use the chain rule. The 2 is going to come down to the front. We're going to drop the power down by 1, and we're going to times by the derivative of the bracket, which is 2. And then v dash is just 1 because x differentiates to 1, and minus 3 is a constant, that differentiates to 0. Okay, so tidying this up a little bit, this becomes 2 times 2 is 4, so we can just write it as 4 lots of this bracket, and of course we don't need to write the 1 there either. Okay, perfect. Right, so the quotient rule is as follows. It is v times by du by dx minus u times by dv by dx, which is 1, all over v squared. So that's x minus 3 all squared. Now, it says where px and qx are fully factorized quadratic expressions. So, what I'm going to do is I'm going to look for factors. So on the numerator, we've got two terms. We've got this term and we've got this term. Now, what do those two terms have in common? Well, they both share a factor of 2x plus 5. Okay, so factorising out a 2x plus 5, what do I need from the yellow term to make, when I take out 2x plus 5, what am I left over with the yellow term? Well, I'm timesing by 4 and I'm timesing by x minus 3. So that works. If I was to expand this bracket out, I would get back to this yellow term. What do I need for the green one? Well, I've got 2x plus 5 squared, so I'm going to need another 2x plus 5 in order to make it squared. And that's it. That is nicely factorised. And then on the bottom, we've still got this x minus 3 squared, which is factorised, so we don't need to worry about that. Okay, so the final thing to do now is just to tidy up this big square bracket. We've got a 4x minus a 2x, so that's a 2x. And we've got 4 times minus 3 is minus 12, and then minus a 5 is going to be minus 17. And then that is again all over this x minus 3 all squared. And I believe that is all good. Yep, that's the final answer. Lovely. Okay. Okay, next part, it says, hence find the range of values of x for which f of x is increasing. Okay, so if f of x is increasing, it would mean its derivative is always positive. Because an increasing function means the gradient of that function will be positive because it's always going up. Okay, so that means that we can solve this function here greater than 0. Okay, so multiplying through by this x minus 3 all squared, which you are allowed to do because it's a square and it's always positive, so it won't flip the sign. And that's going to times by 0, so we just need to solve 2x plus 5, 2x minus 17 is greater than 0. So this is a quadratic inequality. As you probably remember from GCSE, we can find the critical values, which will be as follows. And then if we just do a quick sketch of a quadratic, we should be able to see which way the inequality signs will go. So the quadratic will look something like this, going through minus 5 over 2 and 17 over 2. And we want it greater than 0, so it outputs values greater than 0 here and here. So that happens when the x coordinates are less than minus 5 over 2 or more than 17 over 2. So as two separate inequalities, because it's two separate regions, we write x is less than minus 5 over 2, union, so or x is greater than 17 over 2. Perfect. And it can't be where the gradient is 0 because that's flat and it's not increasing, so it's just strict inequalities here. Perfect. Okay, so now on to the next part. Okay, and interestingly, the way they've this is part I, this is part double I. I think this means that the two parts are not related, so I don't need to use anything of this part in this part. If they were related, it would be A, I, B. I'm not sure if that's true, but I think it is. Anyway. Part II. Let's see if it is related at all. I don't think it is. So we've got a different function, completely different function, which is x, and I'm going to write it as sine 4x to the power of a half. And it's asking us, it says there's a maximum point at m, So we need to find the x-coordinate of m, so we need to solve the derivative equal to 0 basically to find the maximum. So we need to use the product rule here. So u is equal to x and v is equal to sine 4x to the power of 1/2. So we do u dash is equal to 1 and v dash, well, the half comes down, keep the bracket the same, drop the power down by 1 and then multiply by the derivative of the bracket, which is, well, the derivative of sine is cos, derivative of sine 4x is 4 cos 4x. Wowza. Okay, so now we can say g dash of x is equal to, so the product rule states that we need to multiply u by dv by dx and v by du by dx. So let's do this one first. There's going to, okay, actually first, there's a half here and there's a 4 there, so that makes 2. So it's 2, and then there's an x, which comes from here, and then there's the sine 4x to the minus 1/2, and then there's the cos 4x. Right, that was a bit funky the way I did that, but hopefully that makes sense. Times the 2 yellow ones, then times the x, then times the 2 trig functions. Okay, and then we need to add on v du, which is this one times by 1, so that is just sine 4x to the power of 1/2, and because we're finding the maximum point, we want to set the derivative equal to 0. Okay, perfect. Now, we have sine 4x to the minus 1/2 here, so that would be on the denominator, which means that sine of 4x can't equal 0, because then we'd have something on the denominator. So sine, which equals 0. So sine of 4x equals 0 is not a solution. So we can multiply through by sine of 4x to the power of 1/2, and it'll be absolutely fine. Sometimes when you divide by functions, you have to be very careful, you might lose a solution. In this instance, it is absolutely fine. We're multiplying by sine 4x to the power of 1/2. Okay, so in doing so, this gives us 2x, and this completely cancels out. We've still got the cos 4x though. And then over here, we're going to have sine 4x to the half times sine 4x to the half. If we're timesing the same thing together, we just add the powers, so 1/2 plus 1/2 is 1, so it's just sine 4x. And that equals 0. Okay, and now what we're going to do is we're going to divide by cos 4x. And again, cos 4x equals 0 is not a solution to this equation here, because, well, if you sub in 0 for cos 4x, it's not going to make the whole equation 0. So we're fine to do it, and this will give us, so cos 4x divided by cos 4x is 1. Sine 4x divided by cos 4x is tan 4x. And that equals 0, and we have exactly what they want, just swapped around, but I think that's fine. I mean, I'll write it out like this just for consistency, and I'll also say that k is the constant to be found must be 2. Beautiful. Okay, a really lovely question here. These implicit differentiation questions do tend to be very nice. Okay, so we've got a function, got the sketch of it as well, and it says k is a positive constant greater than 1. Okay, that's useful to know. Find dy by dx in terms of x and y. Beautiful. So, we're going to differentiate this function with respect to x. Now, if we are differentiating a function of y with respect to x, then that's a bit tricky. What we really want to do, make it much easier, is if I differentiate with respect to y. That's nice and easy. But these two things aren't equal. Now, to make them equal, we multiply by dy by dx, so that this cancels out there, and now these two parts, left hand side and right hand side of the equation, are equal. So what does that mean for us? It means that if we are doing implicit differentiation, all we need to do is just differentiate a function of y and then multiply it by dy by dx. Okay, so in this instance, that means when we differentiate y cubed with respect to y, we just get 3y squared, but we have to multiply it by dy by dx, as we are differentiating with respect to x, not y. Okay, next one, minus 2x, well that is a function of x, so that just differentiates normally, and that is just minus 2x. And then the next one is a product. So we can use the good old product rule. We can say u is 4x squared, and we can say v is equal to y. So differentiating this one, well that's just a function of x, so that just goes to 8x. Differentiating this one gives us, well, y differentiates to 1 in respect to y, then we have to times it by dy by dx, so we just get 1 lots of dy by dx. So doing the product rule means that we need to cross multiply here, and then add the two together. So this is going to give us 8xy, and it's going to give us plus 4x squared dy by dx, and that's equal to the right hand side differentiated. Well, k is a constant, so it's going to differentiate to 0. Okay, perfect. Now the trick here is you're going to want to collect up the dy by dx's on one side, so bring them all together. And then any term without dy by dx goes over to the other side, so the minus 2x moves over to become just 2x, and the 8xy moves over to become minus 8xy. We can then factorize to get 3y squared plus 4x squared, and that's equal to, again, 2x minus 8xy, and then we can divide through to get our dy by dx that we want in terms of x and y. So it's this over this. Perfect. Okay, that is good. Job done. 5 marks. That is generous for what's quite a kind of methodical process. Okay, let's grab some space and do part B. Okay, part B says the point on C, the point P lies on C. Given that the normal to C at P has the equation y equals x, as shown in figure 2, find the value of k. Interesting. So let's look then at the only relevant part of the graph, which is at P. So what do we know about the gradient of P? Because we do have dy by dx, so what do we know about the gradient? Well, if the normal is y equals x, then it means the normal gradient is equal to 1, so which means the tangential gradient is equal to the negative reciprocal of that, which is minus 1. So therefore the dy by dx at P should equal minus 1. So we can say that 2x minus 8xy over 3y squared plus 4x squared should equal minus 1. Okay. What else do we know at P? Well, at P, it's also on the line y equals x. So that means that at P, the y coordinate equals the x coordinate. So whatever P is, it could be 3, 3, or 4, 4, or whatever, but we do know the y equals the x. So we can use that to our benefit. So in fact, what we can do is we can swap out all the y's for x's. So xy becomes x squared. This becomes 3x squared, and then plus 4x squared, like so, and that's equal to minus 1. Okay, perfect. So we get 2x minus x squared, and then this on the bottom is 7x squared. Times it up here becomes minus 7x squared. We could bring all the stuff over to the right hand side. So add the 8x squared gives us 1x squared, and minus the 2x gives us 2x. Now we can solve, so we can get x minus 2. So x equals 0 or x equals 2. Now it must be x equals 2 because obviously x equals 0 is there and it's not there, is it? So it's definitely x equals 2. Which means the coordinate for p, as we said, the x and the y are the same, so it must be 2, 2. Great. Now, how does that help us find k? Well, what we know is the curve, which we is c. We know it passes through p. So we know that 2, 2 satisfies the equation of the curve. So I just need to sub in to the curve now to find the value of k. So again, at p, we have that the curve y cubed, so 2 cubed, minus x is also 2, plus 4 times 2 squared times 2 is equal to k. So this is 8 minus 4 plus 32 equals k. So this is 36 is equal to k. Perfect. Cracking question that. Absolutely love that. Okay, question 16, differential modelling, and this is an interesting topic. It isn't like an AS topic, but it can always come up in the A level, and I've just got a sneaky feeling it might do this year. So that's why it's on my paper. Okay, so we have a cylinder, and it says express h in terms of x. So we're going to need a bit more information than that, and that is that the volume of each tablet, tablets in solid cylindrical, well, yeah, whatever, is 60 millimeters cubed. So just check millimeters and millimeters. Yep, so that's all good. So we should just be good to say the volume is equal to pi r squared times h. We know the volume is 60, and that is pi multiplied by the r is x, so x squared, and the h is just h. So express h, so we need to make h the subject, so we're going to take the 60 and we're going to divide through by the pi and the x squared. And there we go, that is h, 1 mark in the bag. Okay, next, show that the surface area of the tablet is given as follows. Okay, well, the surface area of the cylinder is the lid, which is pi r squared, in this case pi x squared. The base, which is also pi x squared, so that is 2 lots of it. Let me just write surface area equals, or they just call it A, so just A equals. There we go. Now the curved surface area, if I unwrap it, I think of it like as the label on a tin of beans. It becomes a rectangle with height h, but the width is all the way around the cylinder, which is the circumference of the cylinder, which is 2 pi r, in this case 2 pi x. So to work out the area of that rectangle, it's going to be 2 pi x times by h. Now the trick is with these questions is that we really want a formula, in this case for the area, in terms of only one variable, so only in terms of x. So we're going to want to swap out the h here using this h here, so it's only in terms of x. So we get 2 pi x squared plus 2 pi x times 60 over pi x squared. Okay, great. So the area is equal to 2 pi x squared, and then we've got on top 2 times 60 is 120. Times by pi, no, not times by pi, because the pi's will cancel here. And also we're going to cancel out x, which leaves us with just 1x on the bottom. So just 120 over x. Perfect, as required. So that's part B. And there is the area formula. Okay, good stuff. Now it says use calculus to find the value of x for which a is a minimum. Okay, no problem. We just need to differentiate the function for a in terms of x. So the 2 comes down to make 4 pi, and then we drop the power down by 1. This 120 over x, we're actually going to write that as 120 x to the minus 1 to make it easier to differentiate. So the minus 1 comes down to become minus 120, and then we drop the power down again by 1 to get minus 2. Now we want the derivative to be equal to 0 because that's where we find maximums or minimums. So we're going to set this equal to 0. And then the first thing we're going to do is we're going to multiply through by x squared because that's going to cancel the x to the minus 2. So this gives us 4 pi x cubed. And then this term, the x to the minus 2 times by the x squared will cancel out to make x to the 0, or which is just 1. So it's just 120 times 1, which is 120. Next, we can isolate the x cubed. So add the 120 to that side and then divide it through by 4 pi. And then finally, we can take the cube root of both sides, like so. And this will give us our x value, which I will find on our calculator. Okay, I've just done that, and we've got 2.122. Perfect, so that is 2.122. Brilliant. And then it says calculate the minimum value of a. Okay, to find the minimum value of a, we just take the value of x, which minimizes a, and we sub it into the formula for a. So I will do that on my calculator now. Okay, I've done that and made use of the answer button to get as best accuracy as possible. And that just gives me an answer for the minimum value of a equal to 84.8, and that will be millimeters squared. It says the nearest integer, so approximately 85 millimeters squared. Perfect. Okay, so the next thing is we need to show that it is a minimum. Okay, so to do that, we need to find the second derivative. And I've just deleted the first derivative, so that's not helpful. Let's just delete this, and let's find the second derivative. So the second derivative is equal to something times by x differentiates to whatever that constant is, which in this case is 4 pi. Minus 2 comes down to make plus 240, and then drop the power down by 1 to make a power of minus 3. Okay, so really we are interested in what the second derivative is at the x value, which was 2.122. So if we sub that in, again using our calculators, okay, just sub that in, and I've got 37.7. So that is great, because what that shows is that the second derivative is greater than 0, and when the second derivative is greater than 0, we get a minimum point. If it's less than 0, we get a maximum. If it's equal to 0, we get a maximum, minimum, or perhaps a point of inflection. We need to do further investigation. But for greater than 0, the second derivative means that we have a minimum. Question 17, iteration. We've got a function, f of x. Show that f of x equals 0 has a root on the interval. Okay, perfect. So this is the change of sign method. So what we're going to do is we're going to sub in 2 into the function. So we get 2 to the 4 minus 5 times 2 squared plus 4 times 2 minus 7, which is equal to minus 3, which is of course less than 0. And then we're going to sub in the other limit of the interval, and that is 3. So we're going to write out 3 to the 4 minus 5 times 3 squared plus 4 times 3 minus 7, and that equals 41, and that is greater than 0. And then we are going to write the following, and we're going to do it word for word. We're going to write there is a change of sign, and f of x is continuous, so there is a root in the interval. So the things that underline are the things that you must say. You must say change of sign, you must say that the function is continuous, and you must say therefore there is at least one root, or there is a root. Okay, great. Part B, it says show that the equation f of x can be written as follows. Fine, so let's identify which x they have made the subject, because in order to do this topic you must make the f of x equal to 0 into x is equal to g of x, which they have done. They've got x here and they've got another equal to another function of x, and that has all come from the f of x equals 0. The question is, which x did they choose? Well, to solve the mystery, we're going to look here at the fact that there is a cube root. So, interesting. Okay, the plot thickens. But we do have... I'm actually a bit confused. We've got this 7, we've got the 4. Okay, come on. Come on, we can do this. I mean, this looks very similar to this. So let's get that all over to one side. And then we divide by x, then we cube root. Yes, 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 yes. Come on. Okay, so we do x to the 4 minus 5x squared plus 4x minus 7 equals 0. We're going to move all of that stuff over, so that becomes positive, that becomes negative, that becomes positive. We're then going to divide by x, and this is where the cube root comes in. We're going to divide by x, and then the final step. This is a show that, so I'm not going to try and skip steps here. I'm going to write it out in full. So the final step is to cube root this 5x squared minus 4x plus 7 all over x. Okay, as required. Perfect. Okay, now we've got the iterative formula, which comes from this x equals g of x rearrangement, and it says it's used to find alpha, and we are starting with x equals 2. So this is all calculator work here, and this is, I think, the most fun you're going to have in your maths exam. So you press 2 equals, so that 2 is now stored as the current answer in your calculator. And then to find the next x value, you need to set up the iterative formula, which is the cube root of fraction 5, and we're going to use the answer for x, for the previous x, that is, minus 4 times the previous x, which again we're going to use answer, plus 7 divided by the previous x. Perfect. So pressing equals, this will give us x2. And we just need to write that down. So x2 equals, and what's it to 4 decimal places? So 2.1179. Okay, great. And that's it. That's all we need to do, in fact. We just need to show x2. But now we need to find alpha. So what we're going to do is we're going to find the next x value by pressing equals, and it's going to converge upon the root. So we're just going to keep spamming equals. That's x3, 4, 5, 6, 7. And you're just going to keep pressing it until we get no more changes. Perfect. There we go. So that root is correct to however many decimal places there are there. So we only want the first 4, but this is all good, so it's 2.1565 to 4 decimal places. And that is job done, and I think that's about as much fun as you can have in a maths exam. Okay, question 18, and we've got differential equation, rates of change. A spherical ball of ice of radius 12 centimeters is placed in a bucket of water. In a model of the situation, the ball remains spherical as it melts. T minutes, so always underline the units so you don't get caught out. And again, this is in centimeters. Yeah, that's also in centimeters. Fine. Okay, so the rate of decrease of the radius of the ball is inversely proportional to the sphere, so to the square of the radius. Oh my gosh, I'm not going to lie, I do not like these questions. The radius of the ball of the ice is 6 centimeters after 15 minutes. Find an equation linking R and T. Right. Well, we're going to start here. The rate of decrease of the radius. So when we say rate of decrease of the radius, that means dr by dt. So the rate as in how fast or slow that it decreases over time. And that is equal to negative, because it is a decrease, or should I say proportional to in the first instance, because it is proportional to, and it's inversely proportional to, so 1 over the square of the radius, so r squared. So as we remember from GCSE, when we do proportion questions, we can say this is equal to a constant multiplied through by 1 over r squared. So we can write it as k over r squared. And we've still got that negative there because it's a decrease. Okay. Now we need to find some more information to find the well, we need to find k, don't we? We need 2 bits of information essentially. Now the 2 bits of information is that initially, so t equals 0 and r equals 12, and also t equals 15, r equals 6. Okay, perfect. Those are the 2 bits of information. Now we want to find an equation linking r and t, which means we need to integrate this equation. But first we need to separate the variables. So dr is equal to minus k over r squared dt. And this tells us that the left-hand side is where we want our r's. So we're going to multiply through by r squared to get the r's and the dr to match up. And then we've just got minus k dt there. And now we can integrate this. So integrating the left-hand side, up the power, divide by the new power, gives us a third r cubed. K is a constant. When a constant integrates, it integrates to a constant times by whatever variable we're integrating respect to. So it's going to integrate to minus kt plus the constant of integration as well. So that's why we've got these 2 constants now, but we've got 2 conditions that we could sub in to find the 2 constants. Okay, let's start with the easier one, because t is 0. Let's sub that in. So r is equal to 12. 12 cubed, I don't know off the top of my head. It's a bit embarrassing. But that's what the calculator's for, after all. 1728. Okay, so that's over 3. So 1728 over 3 is equal to, and in this case, t is 0, so we just get c. Okay, so this simplifies to c is equal to 576. And then that gives us our first unknown constant. And next we need to then sub in the next bit of information to get our second. So this equation is, again, it's a third times by r, which in this case is 6 cubed, and then it is minus k times by 15, so minus 15k, and then plus c, which is 576, and this can be rearranged and solved for k to get k is equal to 33.6. Okay, great. So now all we need to do is just write the equation out in full. So we get a third r cubed is equal to minus k, which is this, and then times by t, and then plus 576. Perfect, and that is an equation linking r and t. It doesn't say make r the subject, it just says an equation linking the two variables, which that is. So I think that is job done. Then it says find the time taken for the ball of ice to completely melt. Well, that means that the radius is equal to 0. If the ball's completely melted, then obviously it has no radius anymore. So 0 is equal to minus 33.6t plus 576. So t will just be the solution to that, which will be 576 divided by 33.6, which gives us 120 over 7. Now it's a modelling question, so better give it, I think, as an approximate answer, 17.14, and also the units, and that is minutes. Perfect. Okay, final question, and we have just a straightforward algebraic partial fractions. So we are going to write 1 over h minus 5 h plus 3 can be written as a over h minus 5 plus b over h plus 3. We're then going to multiply through by this denominator, so multiplying by both linear factors. So the h minus 5 will cancel this denominator, but the h plus 3 will still be there. And on this term here, the h plus 3 will cancel, but the h minus 5 will still be there. Okay, and then we let h equal 5. So that gives us 1 still on the left side, and it gives us in here that will be 8a, and this will be 0, so a will equal 1 over 8. And then we let h equal minus 3 to cancel out this other bracket. The 1 on the left stays the same. This bracket does cancel because h is minus 3, and this one becomes minus 8b. So b is equal to minus 1/8. So it does ask us to write it in partial fraction form. So my final answer will, or should be, that this, like that, should equal, you could write it in one or two ways. You could write it as 1/8 over h minus 5, or you could write it as 1 over 8 lots of h plus 3. But the b term is negative, so this should be a negative. And in fact, I am just going to write it in the same way as I did the first one. So minus 1 over 8 would be correct. Okay, that's that done. Okay, next part is part B, and we have this differential equation that needs to be solved, basically. Just always, again, highlight the units, and t is in days, because that can mess people up. I've seen it happen hundreds of times. And it says the initial depth of water is 13 meters. So that means that when t is equal to 0, h is equal to 13. So we need to separate the variables. So the first step I'd always do is multiply by the dt, the bit that's down the bottom here. This gives me minus h minus 5 h plus 3 all over 40 dt. And then I'm going to want to move these two linear factors. I'm going to divide both sides through, which will give me 1 over the h minus 5 h plus 3 dh. And then I'm left on this side with minus 1 over 40 dt. And that's good. And this is a follow-on part from the previous question. And of course, this we've already partial fractioned. So I can rewrite this as, let's take the 8th out. And then I have just 1 over h minus 5 and minus 1 over h plus 3. And that equals the integral on this side. Oops, sorry, I need to put dh in there. And that equals the integral on this side, which is just minus 1 over 40 dt. Okay, we can multiply both sides by 8. That's going to help simplify things slightly. So timesing through by 8 changes this into 1/5 as opposed to 1/40. It cancels out the 8 there. That's nice because I can see these 0.2s here, which is going to be where this the 1/5 comes from. So in fact, I'm going to change this to minus 0.2 rather than 1/5. Okay, and then we're going to integrate these. So this is just a straightforward ln integral because the derivative of that fraction is just 1 and the numerator is 1, which means we can integrate this to just ln of h minus 5. And this one, again, there's a minus there, but this is just going to integrate to ln of h plus 3. And on this side, this is going to integrate to minus 2 as a constant, so we just integrate this by multiplying by the variable we're integrating with respect to, which is t. Perfect, and then plus a constant, and we'll put the constant over there. Great. Okay, let me just grab some more space and we will tidy up and find our answer. Okay, so I'm just going to combine those two lns, because when we've got one log minus another, we can write that as log of, in this case, h minus 5 on top and h plus 3 on bottom. I think that's just going to make things a little bit easier. And then we're going to sub in our conditions to find c. So we have t is 0, h is 13. So let's sub that in. So we get ln of h is 13, we've got 13 minus 5 is 8, over 13 plus 3 is 16. So that is a half. And that equals, well, t is 0, so just c. So we have ln of a half is c. Perfect. So let's just replace the c here with ln of a half, and we are good. Okay, so this is it. We just need to make h the subject now, which is a bit easier said than done, isn't it? What I'm going to do is I'm going to bring the lns together. So this gives us minus ln a half on this side, and that's equal to minus 0.2t. And now we can combine these lns once again because we have one minus the other. So this means that we're going to take the first input and then we're going to divide it by the second. And dividing by half is the same as timesing by 2. So therefore we can say this is ln of 2 times this, so 2h minus 10 over h plus 3. And that's minus 0.2. So once again, you've got two lns, you're subtracting them, it means that we're going to divide the inputs, and if we take the yellow and divide it by half, it's the same as timesing it by 2, so you're just going to times the numerator by 2 in order to make the whole thing times by 2. And now, this is perfect time to take the inverse of ln, which is raising both sides as the power of e, which is the base. So it becomes e to the minus 0.2t, like so. Perfect. Okay, so now the next thing to do is, again, we want to make h the subject, so that means that we need to just rearrange this equation so that h is the subject. It appears twice in this equation, so it means that we are going to have to use our GCSE skills to collect up all the h's, factorize, and then make it the subject. So we get this when we multiply up the denominator. We then can expand out to get h e to the minus 0.2t plus 3e to the minus 0.2t. We can then bring all the h's to one side. Just be a little bit careful to pick which side to do it. I can see here that there's going to be a positive 10, so I want the 10 to go to the right side. So let's do 2h minus h e to the minus 0.2t, and that's equal to, so the 10 comes to the other side, so 10 plus 3e to the minus 0.2t. Okay, so just bringing all the h's to the same side, which then will allow us to factorize to get 2 minus e to the minus 0.2t is equal to 10 plus 3e to the minus 0.2t. Perfect. So now h is equal to 10 plus 3e to the minus 0.2t all over 2 minus e to the minus 0.2t. Beautiful. Cracking question that. Okay, on to part C. Okay, it says, hence find the time taken for the depth of water in the tank to fall to 8 meters. Just once again check the units. We're not going to get messed up by that, because sometimes they can really mess you up, and like switch the units out just to mess you up. Anyway, they're not doing that, so it's fine. Depth of water to 8, so that is h, so we want h to be equal to 8. So essentially we are just solving this equation. Oh, you are kidding me. So now we need to rearrange to make t the subject. Oh, this is going to take ages. Okay, so we kind of have to do exactly the same skill as we've just done, and that is to multiply up the denominator like so. In fact, actually, this is not going to be as difficult, is it? This is fine. This is fine. Okay, no, it's all good. So yeah, just take the denominator, multiply it by 8. So multiply it up to this side over here, and then we can just get all the e's on one side. So minus the 10, which gives us just 6. Add the 8. E to the minus 0.2t, which gives us 11e to the minus 0.2t. Fine, so divide through by 11 gives us this. Take the natural logarithm of both sides, gives us this, and then times through by minus 5 gives us this, or divide by minus 0.2, same thing of course, and then that just needs to go into the calculator. So there it is, minus 5 ln of 6 over 11, and it gives us 3.03. Does it say, it says time taken, and the time taken is in days, so I think we're just fine. We'll just go 3.03. So that equals 3.03, and that is days. Always give you units. Okay, brilliant. According to the model, the depth of the water in the tank will eventually fall to K meters. State the value of K. Okay. Well, when T tends to a huge number, we know that e to the minus of a huge number will be 0, tends to 0. So essentially these will just cancel out. So it looks to me like h will tend to 5, 10 over 2. Now, if you enjoyed this paper and you found it useful, then please do consider supporting the channel. And the best way you could do that is signing up to my live session. So check it out. It's a great way to support the channel, and hopefully it'll be really useful for you too. In the meantime, good luck in your exams. Bye for now.